Ever wondered how a modern airliner is born?
See how your next flight was built, step by step.
The stress simulation on the new composite layup looks good here.
Yes, the thermal load distribution is optimal.
We need to adjust the cushion density.
The material test results look promising.
Finalizing the airflow schematics now.
Ever seen landing gear being tested before takeoff? We assemble the strut, attach the wheels, and simulate deployment. Then the full function check.
This is what happens when engines meet the wings. Prepare pylon mounts, lift turbofan engine into position.
Shape door frame from composite, install locking mechanisms, integrate emergency slides, seal pressure gaskets, and
This is how airplane seats are made before installation. Weld seat frames, mold foam cushions, wrap
neutrals, attach fuselage shell onto rotating jig, weld pressure bulkheads, install floor beams, add insulation layers, route.
We simulate the gear motion, followed by a leak detection scan and fluid circulation test. The system is fully approved. Before the paint, there's a process you never see. Sand aircraft exterior, clean with solvent, apply corrosion. The airflow is strong here, but this vent needs adjustment to balance the climate zone.
How flight computers get tested before takeoff. Install flight management systems, connect to Avionics backbone, load.
All pressure systems check out.
Good. Connect the emergency power and let's finalize the audit.
cut fuselage panel openings, place inner structural rings, fit composite window frames, insert pressure-rated glass.
This is how the aircraft tail fin comes together. Manufacture vertical stabilizer bar, attach ribs and skin.
Initiating comm system check, VHF-1, transmission clear.
Affirmative. Receiving strong signal on all bands.
Assemble carbon brake discs. Install in wheel hubs. Mount brake calipers. Connect hydraulic lines and assemble bin modules in workshop. Install ceiling mounts in cabin. Lift and lock bins into place.
Ever wondered how aircraft fuel tanks are built? Install sealed tank liners in wings. Add baffles and sensors. Connect refueling ports.
What is the last step before delivery? Wash aircraft exterior, polish cabin window.
Roll out insulation mats, secure between fuselage and wall panels, apply vapor barriers, inspect for coverage gap.
Warning, system diagnostic active. Flaps not engaged. Autopilot check complete.
Wiring harness is secure. Good.
Let's run the brightness sequence and simulate the nighttime conditions. Keep an eye on the clarity.
Mount full aircraft on stress frame. Apply load to wings and fuselage. Monitor formation sensors.
Assemble lavatory modules. Install plumbing and waste systems. Test water flow and flush. Mount to cabin structure.
First, install the external power ports and connect the GPU cable harness. Then, simulate the
This is how pilots' oxygen systems are installed. Mount oxygen cylinders in cockpit bay, connect to the regulator system.
After installing the crossbeams and composite floor panels, they are bolted securely. Vibration dampeners are added.
Fit radar dome supports, mount cockpit frame, integrate front pressure bulkhead, align nose cone, wire radar electronics, seal and verify shape symmetry.
After connecting the control rods, we test the pitch movement and verify the response from the cockpit input. Weld the wing spar structure, insert the ribs and structural supports, skin with composite sheets, apply bonding adhesives,
Shape aluminum panels, attach hinges and locking system, install pressure seals, connect motorized actuators, test door cycle under cabin pressure.
We begin by sealing the fuselage openings and filling the cabin with high-pressure air. Then,
shaping the cone from composites, installing the APU exhaust, integrating lights and sensors, attaching it to the fuselage end.
How emergency floor path lighting is installed. Lay LED strips along cabin floor tracks. Connect.
We mount the door onto a test rig, simulate cabin pressurization, perform opening and closing cycles, test the emergency.
Air packs are mounted below the fuselage, ducts routed through the cabin, then sensors and temperature controls connected.
The process involves molding the plastic vents, assembling the nozzle units, and connecting them to the
Pneumatics are reading steady at 50 psi.
Confirmed. Hydraulic pressure is nominal across the board. We are green for engine start.
Inspect every rivet and panel gap. Use a bore scope for hard-to-see areas. Scan for dents and corrosion.
Mount battery packs in sealed bay. Connect to power distribution box. Test voltage levels and simulate backup power switchover.
Heating elements are installed in the wing leading edges, followed by the connection of temperature sensors.
We install the illuminated seatbelt and exit signs, wire them to the emergency circuits, and then test their visibility in low light by simulating a loss of power. Install outflow valves, connect to pressure sensors, simulate climb and descent cycles, monitor cabin pressure stability.
Install potable water tanks, route plumbing to galleys and lavatories, connect pumps and valves, and run flow and leak tests. Mount waste tanks and vacuum pumps, connect toilet outlets, test flush cycles and seal integrity, and verify no backflow.
Monitor the differential pressure closely during the flow check.
Confirmed. System test sequence initiated.
The curved windshield panes are carefully aligned and fitted into the fuselage frame. High-pressure seals are
Position seats onto floor rails, bolt down securely, connect electronic adjustments, and test recline and movement.
Significant turbulence registering. Maintain approach speed. Copy that.
Airspeed steady. How are the hydraulics, Sergeant C?
All parameters green, Captain. Feedback within tolerance.
We have stabilization at cruise altitude.
All systems reporting green. Integration verified.
What's included in final delivery documentation?
Print serial numbers, component checks, test results, verify Q team, and
Insert cards into seat pockets. Mount emergency guides on walls. Place fire extinguisher instructions in galley.
Apply interior pressure. Check door seals and hinges. Run cycle tests over thousands of opens and closes. Mount tires on landing gear. Inflate to spec PSI. Test for heat expansion and confirm pressure sensors. Aircraft galleys are built by assembling modules with ovens and carts, then installed into the fuselage.
Activate under simulated power loss. Verify location and brightness. Then test the battery backup function.
Apply insulation to sidewalls, floors, and ceilings. Measure noise levels in the simulation booth and adjust layers for optimal comfort.
Review pre-flight documents, inspect cockpit instruments, power up all systems, verify control surface movement.
The polish on this fuselage is absolutely flawless.
It truly is a work of art.
All right, team, the customer walkthrough is in 10 minutes. I've checked off the final items here. Ensure all access panels remain closed unless demonstrated.
We scan the serial codes into the database, then apply the RFID tags.
Mold tire rubber layers, bake in curing oven, reinforce with steel belts, test load resistance, and ship to assembly line. Collect maintenance tools specific to the aircraft model, calibrate the instruments, pack them in sealed cases, and document for delivery.
Engine 1 to idle, stabilizing.
Yaw warning, engine.
Restart protocol engaged. Confirm successful relight.
Accelerate down test strip. Check brake systems. Monitor wheel sensors and vibration. Simulate sudden stops.
Install seat rows with laser guides. Then measure the legroom from the seat back to the front. Reposition the
Mount antenna on fuselage. Install router units in ceiling. Connect to cabin network. Test upload/download speeds. Install sensors across structure and engines. Route to central monitoring computer. Simulate fault alerts. Test ground communication.
Test rigs. How temperature is controlled in different zones. Place sensors in cockpit, cabin, and cargo.
Securing the flight deck involves mounting the bulletproof frame, installing the electronic lock, wiring it to the control system, and testing the emergency override. We fabricate the ducts and filters, mount them to the engine housing, test the airflow and pressure drop, and finally confirm the sealing.
Sensors inserted, beginning the fuel simulation now.
Hot conditions achieved. Monitoring vapor release points. We have a confirmed leak at the valve.
Row 25 markers are installed and labeled.
Okay, cross-referencing with the digital map. Configuration confirmed.
Laser tracking systems check the dihedral angle. Adjustments are made using shims, then verified precisely in the 3D model. Charge batteries to full, simulate power loss, monitor backup system switchover, and record discharge times.
Discover how exit signs are tested in darkness. Turn off all cabin lights, trigger emergency mode, and check brightness and visibility from all angles.
As you can see, the FMS is fully integrated.
Confirmed. Performance margins are well within target.
Very good. The airline will be pleased.
We weigh the fuselage, wings, and systems, input the data into the balance software, adjust the cargo layout,
and mount tanks with vibration dampers. Seal all joints with aviation-grade epoxy. Pressure test for leaks. Connect to vacuum lines. First, the panel is installed in the seat back and connected to the data lines. Then we run the response tests before simulating the software update.
First, align the grill unit to the cabin duct. Then snap it securely into the ceiling slot.
Mount the unit securely and check the pressure indicators. Next, test the pull handles and confirm the signage and inspection tags are up to date.
First, print safety-only decals. Then position them using laser guides, apply with a pressure roller, and finally seal the edges for durability.
Pack slide inside door housing. Simulate deployment. Verify full inflation within time spec. And repack for readiness.
All right, clear for lift. Begin ascent slowly.
Undercarriage is clear, steady as she goes.
Mount APU at tail. Connect fuel and power lines. Run startup cycle test. Measure vibration and heat output.
We scan the fuselage under polarized light, checking for bubbles or streaks. Then we sand and repaint. During the final torque check, we revisit critical fasteners across the aircraft, use calibrated torque wrenches, log each.
First, we measure the sill height, then align the frame. The extension mechanism connects securely before we finalize the ground contact test.
The process involves drilling nozzle holes at the leading edge, connecting fluid lines, installing the pump system,
We mount the dampeners directly onto the cabin frames. The shakers simulate the turbulence, and
after aligning the pins and checking the seal, we precisely adjust the hinges before running the test cycles.
Mount in reinforced tail section, add vibration and fireproof casing, connect data cables, and verify recording activation.
Load airline seat layout files, install components per plan, verify with 3D walkthrough, and adjust for specific airline specs.
Testing 1, 2, 3. This is a test of the flight attendant panel and passenger address system. The lighting controls are responding.
the process involves installing the attachment points on the door frame, followed by fitting the mechanical latches and sensors before the final deployment simulation.
Keep it coming straight, looking good.
Hold that line just a few more feet.
And stop right there, brake set.
We use filtration systems in paint and assembly areas, monitor dust and humidity, and ensure cleanroom standards in critical zones.
First, install the lighting controller unit and connect the LED strips. Then, set the day and night presets and test the color transitions. Secure your mask immediately. Remain seated and keep your seatbelt fastened.
Cut panels to fit space, apply adhesive layer, press down anti-slip sheets, and test grip under wet conditions.
Use stencil templates, then paint or stick the regulatory markings. Finally, verify the location against the certification guidelines. Static wicks are mounted on the wings and tail, connected to the grounding system, and then tested with an artificial static buildup.
We've covered the checklist and installations.
All systems tested and green.
Perfect. Finalizing the sign-off now.
How is the airflow now?
Perfect, much more comfortable.
As you can see, the handover checklist is fully digitized. Let's review the system tour and walk-around points now.
And this covers the hydraulics access, correct?
Mount overhead sleeping compartments, connect ventilation and lights, and install mattress and safety equipment. The process involves fitting composite covers over the joint, followed by sealing and bolting, and finally testing the mount ropes above exit windows, test drop distance, verify strength rating, and store in quick access cases.
Shine intense lighting at every surface. Check for surface flaws, paint errors, and dust. Then mark corrections with tape.
We submit the final review for approval.
Congratulations. Here is the certificate of airworthiness.
This gauge here monitors the hydraulic pressure.
Ensure the coupling is secure before you open the valve.
These binders contain the full maintenance protocols.
Discover how airframe joins are sealed.
The resistance across the bonding straps is nominal.
Initiating the surge sequence now. The discharge path looks clear.
We roll into the dark hangar, activate navigation, landing, and strobe lights, then verify the brightness and alignment.
Install shielding mesh around sensitive avionics, test for magnetic interference, and confirm protection under various loads.
The drill is concluded. Total evacuation time, 3 minutes and 12 seconds. Please wait for further instructions.
Grease all mechanical hinges and joints. Inspect fluid levels in hydraulic systems, and document intervals for relubrication.
After connecting the cart and monitoring levels, we ensure no leaks and record the logs. The fueling is now complete.
It is our pleasure to officially hand over the keys to your new aircraft.
Thank you. We are excited to welcome it to our fleet.